Okay, we have a problem here that says use the indicated change of variables to evaluate the double integral. Round your answer to 2 decimal places. We're given that the substitution is x equals u over v and y is b, and they've provided the picture for us here. So what do I need to know? I need to know bounds for u and bounds for v, and I need to plug in these substitutions into my integral, and I need to calculate my Jacobian. So let's start with calculating the Jacobian. So that was del of x and y over del of u and v is equal to, I need del x del u, del x del v, del y del u, del y del v, and we'll take the determinant of that. And so it looks like by my substitution, I should have del x del u should be equal to 1 over v. Del x del v should be equal to u times natural log of v. Del y del v, del y del u should be 0, and del y del v should be 1. So when I calculate the determinant, I get 1 over v times 1 minus u natural log of v times 0, which is 1 over v, an absolute value of that. Okay? So it looks like if I want to set up my integral, I can replace y by v, and then I have sine of x times y. Since x is u over v and y is v, this is u over v times v, so it's u. So that's v times sine of u, and then times 1 over v because of my Jacobian, and I can integrate du dv. Alrighty. Then I need to know my bounds for u and v, and that's where I'm going to refer to my picture a little bit. So my x is u divided by v, and we just found out that x times y was u. So if I want to know my bounds for u, the picture tells me that I have x times y equals 1 is this curve, and x times y equals 3 is this curve. So I'm going to say that my bounds for u are from 1 to 3. And I can clearly see that y is running from 1 to 3 as well. And y is equal to v, so this will also be my bounds for v. So this integration should be integration 1 to 3, integration 1 to 3, sine of u, du, dv. And so the antiderivative of sine, of course, is negative cosine. So this is 1 to 3, negative cosine, evaluated between 1 and 3. I forgot my variable there. Negative cosine of u evaluated between 1 and 3. So that should be integration from 1 to 3. Minus cosine of 3. Minus times minus is plus cosine of 1. And those are just constants. So it's going to be minus cosine of 3 plus cosine of 1, the constant, times the antiderivative of v. of dv, which is v, evaluated between 1 and 3. So I got minus cosine of 3 plus cosine of 1, all of that times 3 minus 1, which is 2, of course. So 2 times cosine of 1 minus 2 times cosine of 3. Well, it looks like that's as good as we can get for integrating this function using the given substitution.